the next topic what we have to see is STM32 system architecture. We had already seen the system architecture in the previous lecture, but that was most uh, general system architecture. Now we will see little more specific two different types of system architecture. The first one is in small, medium, and large scale capacity products. The main system consists of the following parts. For example, it has 4 drive units and 4 passive units. But here you can see in some other connected and complex products, the main system consists of 5 drive units and 3 passive units. So it's different. So it's really based on the application where you are going to use the microcontroller. You have to choose the right system architecture. How can you choose the system architecture? You have to go to the data sheet of each product and then look into the detail and then decide which one you want to use. That is for commercial projects or some more complex projects. So here we have already given you which one you have to use. Of course, you are free to buy or use any other microcontrollers if you want more advanced versions. So you can just see the differences, and each drive unit mainly have the cortex. That is important, and then the how many DMA they have. Here we have DMA1, DMA2. Here also we have the DMA1, DMA2, and then according to the connection interface, this one has Ethernet DMA also. And the passive units you can see here: internal SRAM, internal flash memory, and the flexible static memory, and the AHB to APB bridge. This is the high speed bus, and then the low speed bus we had seen just before. So this one high speed one have master, slave, and basic structures. APB has APB1 and APB2. So which connects all the peripherals to the system bus or system matrix, and then it will connect to the core. So all the data will be connected to the core and then the DMA from this through these bridges. There is the DMA. DMA is here. So similarly, this is another type of architecture. It has a different number of drive units and passive units. So here you can see internal SRAM is there, internal flash memory, but it doesn't have the static memory. And similarly, it has also AHB and APB bridges and the connectors, buses, and so on. And if you look at this architecture, you can see there are different buses. As I said, some of them are used for data transmission or data transport. Some of them used for address transmission, and some of them are used for clock signal transmission. So here you have iBus, DBus, system bus, and we have the AHB. There is the high speed, and we have the bridge, 2 bridges, and we have the APB1 and APB2 for the different peripherals. So in both cases, all units are connected to each other through a multi-level bus architecture. Here we have multi-level bus architecture. I-code, so it means like we have I-code bus, decode bus, system bus, DMA bus, bus matrix. So everything is here, multi-level bus. These are the actual architecture of these 2 core. This we had seen. So here you can see how the architecture looks like. So what is the difference between this one and this one? What you can see here. So here you can see it's kind of similar, but if you look at more closely, you can see here the clock speed is 72, and here the maximum clock speed is 36 megahertz, and the flash memory and then the other memories are similar. But here you can see here it supports the image sensor, clock control. It has clock control, but it doesn't have the image sensor, and it has only one DMA, and here also DMA, 3 to 11 channels, the same. And what are the other differences here and here? So here you can see this 6 times 16-bit PWM pulse width modulation timer, but here we do not have that. And here we have this external interrupts, and we have this IOs and so on, and everything else is the same. And what else the difference? So here we have the two DAC, but here we have, you see, two ADCs, and in this architecture we have just only one ADC, and so on. So here you can see it supports several interfaces. So it can support USB interface, SDIO interface, CAN bus interface, and ESPI I2S interface. But here this one is not really supporting that much interfaces. So that is how the cost varies based on the features you want to have in the microcontroller. So you can see some features are more in this architecture than this one. So generally, these are the architectures. And I told you in the beginning of the lecture, this is the cortex. This is the core from the ARM. You see ARM? So all other blocks are developed by the manufacturer. For example, in this case, ST Microelectronics, they are the one who developed these other blocks and inserted to the, in the same chip together with this core. This is the core introduced, they bought from ARM, and they developed other blocks, and they put everything together into a single microcontroller, and they define the pin numbers and so on, so many pins in and out, GPIO pins, and they introduce this one to the market. So as a user, we just buy this and we use this. So this is the system architecture. So we have the memories and we have the DMA. So when sometimes we directly read this from the memory to this direct memory access block, we do not need to use the CPU resource. So sometimes we need to transfer the data back and forth all the time during the operation. So we cannot really use the CPU to take the data. So if, for example, instead of reading the data directly from the memory to this DMA, and maybe it's going to the registers, if I use the CPU, then what will happen? So the CPU resource will be occupied, maybe more than 50% of the CPU resource will be occupied by the memory transfer. So we do not want that. So we want direct memory access. That is the concept of the direct memory access. So we have these DMA blocks. This is really helping us to speed up and achieve high performance, and also to achieve low power. Okay, that's all about the architecture of STM32 microcontroller. And here you can see the power supply. So that is the one we are giving the power supply externally, and then the power supply is given to other units inside this microcontroller to drive them. And we have the oscillators to generate the system clock. So there are different types of oscillators can be used inside. And we have the paste lock loop, that is a PLL. So these all are to generate the clock. The clock signals are synchronizing the operations between different blocks and controlling everything, including the time delay. So there are two architectures we had seen just before. One is using 72 megahertz. That is, you can choose this kind of architectures where you need for high performance. This is for the performance line. And the other architecture where you just need for general purpose applications and access line. It can be called access line, and it does not have many interfaces as this architecture. You had seen this one have so many interfaces: USB, CAN, AZ, timer, I2S, and SDIO. Here we don't have anything. So that is what I said here. So we have more interfaces, and here we don't have interfaces enough.